Hi, this is John Cross with Ohio Lumex. Today I'm going to give you a general overview of the OLM30B sorbent trap sampling system. If you've already got one of these samplers, this video may help you discover some of the features and options available for the OLM30B that you didn't know about. If you don't own an OLM30B, this video will provide you with a fairly comprehensive introduction to the sampler and its capabilities. Let's start by going over the basic components. The core components of the OLM30B sorbent trap sampler include a 6-foot stainless steel probe, 2 desiccant canisters, and a sampling console. The probe includes 2 10mm trap liners, which is where the sorbent traps are inserted. Although mercury sorbent traps are the most popular type of trap sampled with this equipment, you can also sample HCl, ammonia, SO3, or selenium and arsenic with the OLM30B. The cooling air inlet is used to attach either compressed plant air or air from a portable blower to the probe in order to bring probe temperature down in particularly hot sampling environments. The cooling air is pushed down through a cooling tube into the interior and then exhausted at the back of the probe. The desiccant canisters contain 2 materials. This layer is the actual desiccant, and it changes from blue to pink over time as moisture is collected. This serves as an indicator to let you know when the material needs to be replaced. Up here, we have sodium carbonate, which will remove acidic gases from the sample stream in order to protect the console from damage. This is the sampling console. Since there are 2 sampling trains, the console contains 2 pumps and 2 mass flow controllers. The console also includes an oxygen sensor if that option is selected upon purchase, as well as individual vacuum gauges for each sample train and a watt-low temperature controller that can be used to regulate the 750-watt probe heater. The OLM30B sampling system is used for a variety of applications in multiple industries, with the most common application being the sampling of mercury sorbent traps during Relative Accuracy Test Audits at coal-fired utilities or cement plants. The OLM30B is also used to confirm mercury process monitor readings, including both total and speciated mercury concentrations. In more recent years, the OLM30B has been used to sample a variety of non-mercury sorbent traps for applications such as determining the effectiveness of lime-based material injection for removal of SO3 from the gas stream, measuring ammonia slip, using EPA OTM40 to measure HCl stack emissions for compliance, and finding the correlation between alkaline material injection rates and arsenic concentrations upstream of an SCR. It's very easy to operate the OLM30B. I'll walk you through a step-by-step demonstration so you can see for yourself. Before you begin sampling, the first step is to ensure you know all the appropriate sampling parameters for your specific application. Every type of sorbent trap has a unique set of sampling parameters, and the way you sample the traps will most certainly depend on the characteristics of the sample gas, such as temperature and whether there is significant particulate matter in the gas. Our sampling experts will guide you through the specific procedure for your application. That being said, once you know the sampling requirements for your application, you can set a few parameters on the console. To adjust probe temperature, use the up and down arrows on the watt-low controller. To adjust sample flow rate, push the left arrow button on the mass flow controller to activate edit mode, and continue to push the button until you reach the digit that needs to be changed. Use the up and down arrows to adjust value, and push enter when finished. You can also adjust the total volume the sampler will pull. Every time you turn off the pumps, the volume totalizer is reset to 0, and when you turn the pumps on, they will stay on until the target volume is reached. To adjust the target volume, first push the display button twice. You should see a 0.0 displayed. Hold the left arrow button until the display changes to 0.rng. Push the down button twice. Now you should see EA.low displayed. Push enter to enter edit mode, and use the left arrow to scroll through the digits and adjust the volume to your desired set point using the up and down arrows. Note this volume is in liters. Now repeat this process for the other mass flow controller. The next step is to insert your sorbent traps into each trap liner. There's a ferrule inside each one of these compression fittings. Make sure they are pointed with the tapered end toward the back of the traps. Screw the compression fittings to nearly hand tight. Try to rotate the sorbent traps. If the compression fittings are tight enough, they should not rotate. You may need to use a wrench to get the fittings tight enough, but don't over-tighten or you'll break the glass. There's one more thing you need to do before inserting the probe into the sample gas, and that's to perform a leak check. This is straightforward. With the sorbent trap caps in place, turn the pumps on and wait for the sampling trains to be evacuated. Once you see the flow rate is stable at 0, you've passed your leak check. Technically, the allowable leak rate is less than or equal to 4% of the set flow rate, but with this sampling system, you should be able to hit 0 every time. Once you've passed the leak check, you can turn the pumps off and slowly remove the trap caps. Now you're ready to insert the probe and start sampling. Be careful not to break the traps while inserting the probe. Ideally, you should have some way of sealing the probe to the port, and there are a variety of ways to do this, including port stuffers, a flange with a 2-inch O-ring, or in this case, a cam lock adapter. Now that the probe is secure, turn the pumps on and wait for the sample volume to be reached. Monitor your flow rate and temperature to ensure they are stable. Vacuum should also stay below a certain threshold, but that threshold depends on the application. Consult with our sampling experts for further information on this. Some applications will require certain accessories and modifications to that procedure. Our sampling experts are available to help you go through those procedures in detail, but allow me to briefly introduce you to some of these accessories. This is a reference gas flow meter, or RGFM, and it's a NIST traceable flow meter that you can use to confirm the flow rate indicated on the sampler's mass flow controllers. If you're using the OLM30B sampling system to sample Method 30B traps as part of a Relative Accuracy Test Audit, you'll need to use an RGFM to perform a post-test calibration check, according to Section 10.2.2.5 of Method 30B. The pressure side of the RGFM needs to be hooked up to the exhaust of the sampler while the sampler is pulling actual stat gas at an intermediate flow rate, put into continuous flow measurement mode, and then allowed to stabilize for several minutes. Once the RGFM's internal temperature is stable, you can begin recording RGFM flow rates in order to calculate an average and compare to the selected flow rate. This procedure will need to be done for both sampling trains. Refer to Method 30B and contact Ohio Lumix for more detailed instructions on how to perform this procedure. This is a titanium probe shield. It's used to protect your traps from direct water entrainment if you're sampling in a very high moisture environment, such as a wet stack. To attach the shield, place it over the compression fittings at the tip of the probe and tighten the screw. Now keep in mind, the probe shield is not appropriate for all applications. We recommend you contact us to discuss your specific application in order to determine whether it is appropriate to use the shield. As an option, OLM30B sampling systems may include an oxygen sensor. This is useful if measuring the same analyte at multiple locations in a process stream, or if the measurements must be expressed in an oxygen-corrected basis. For some applications, such as sampling for arsenic upstream of an SCR, or sulfuric acid in a wet stack, it is necessary to use specially designed isokinetic sampling equipment to ensure a representative sample is withdrawn. These compounds, among others, exist as an aerosol or fine particulate under certain conditions, and therefore require an isokinetic sampling method. This method is relatively complicated and requires special training. The fine temperature control kit contains a few components, including a Chicago fitting to connect to plant air, valves, a low-pressure air hose, and an inline thermocouple. Many sorbent trap applications require the traps to be maintained in a narrow range of temperatures, and this kit gives the operator the means to do so. The inline thermocouple provides the most accurate measurement of trap temperature possible because the end of the thermocouple rests inside the trap liner immediately behind the trap. It is inserted through the back of the probe liner like this, and then secured to ensure a leak-proof connection. The fine temperature control kit includes two valves. One serves as an on-off valve, while the other is a fine control valve. If you need to use the valve system to sample sorbent traps, we will provide training to ensure you are proficient with the technique required to find the equilibrium between duct heat input and cooling air input. The OLM30B sorbent trap sampler is easy to use, lightweight, and portable. Its rugged construction ensures it can withstand even the harshest of sampling environments. The OLM30B can be used for relative accuracy test audits, engineering studies, and control technology optimization. It is compatible with a variety of sorbent traps, including those for mercury, SO3, selenium and arsenic, HCl, and ammonia. For more information on the OLM30B sorbent trap sampler, or if you're interested in learning about our in-depth sorbent trap sampling training sessions, visit our website or call us and ask to speak with one of our sampling experts.